Hello everybody, this is Team 33 Precise back. I'm talking to you is Mazin and Al-Omairi, and in the team there's Mary, Rachel, Julia, and Trey. We're gonna talk about our FED project to you today. Today we're gonna talk about how we made our FED project. So we're gonna talk about the challenges we had, or the main challenge, and then how we used the design cycle to really form the project accordingly, and then we'll tell you what we learned. The challenge was to build a projectile launcher using zero initial energy. We only use potential energy using a 5 pound weight. The launcher will aim on a target that is 30 feet away.
To build our project, we used the engineering design cycle. On the next slides, I'll talk about how we used each of the steps in the cycle to build our project. We began by identifying the needs and constraints for the project. We knew we could only use a 5-pound weight, that our launcher needed to launch the projectile 30 feet, that we had to start at a zero energy state, that we had a $40 budget, and that our project had to fit inside an imaginary 4-foot cube. We used these constraints to help plan our project. The next step was to research and imagine possible designs. We began by reading articles about projectile motion and energy and researching possible launcher designs. Then we used our research to brainstorm possible designs for our launcher. After our research, we were able to draw our first design, and this is that design. The next step was to create our project. To do this, we gathered our materials and went to the craft center on campus, and that's where we spent most of our time building the project. While we were building our project, we also tested it multiple times. At one point, we decided to use a PVC pipe instead of wood, but after testing it, we realized that wood was the better option. After that, we built another prototype, which was made out of wood, and we tested that, and it was able to launch the ball for over 10 feet, but not quite to 30. While testing our project, we had to make many improvements along the way. One of these was the example I mentioned before, where we switched from wood to a PVC pipe and then back to wood. We also made many improvements on the actual block of wood that launched our projectile when it was pulled back by the bungee cords. Originally, we had a large block of wood and realized this would be too heavy to be pulled forward fast enough to launch the ball, so then we moved to a thinner piece of wood. We also had to redesign the actual launching device that the ball was situated in to make the bungee cords fit through it. There were many other improvements that were made along the way. After going through the engineering design process, we came up with our final product, which is pictured here. A 5-pound weight was connected to a string, and when the string was dropped, it ran through 2 pulleys and pulled back a metal spring. This spring was connected to a magnet, which was also connected to a block of wood. When the spring was pulled back through the small wooden gate, it let go of the magnet, and the bungee cords attached to the block of wood pulled it forward. The ball was in front of this block of wood, so when the wood was pulled forward, the ball was launched. At FED, we weren't able to launch the ball the full 30 feet, but we were able to launch it 10 feet. However, it did not hit the target.
So we learned a lot from FED. One of the main things we learned were how to use some tools in the craft center, the drill, the saw, and how to cut wood, how to measure things, give it a right angle, and all of that stuff. We also understand that not all theoretical designs hypothetically work in real life. Sometimes you may think that things will work perfectly, but in real life it doesn't really work. Another thing is that the projectile weight can make a big difference, more than you can imagine. Um, uh, the more weight you give, different angle, different distance, and a lot of things, even the atmosphere, may impact. Another thing is that we thought there was only there weren't really numerous ways of making a projectile launcher. But in FED, we saw that there's lots of designs. Everyone was different. Everyone was distinctive. So that really gave us a feeling that engineering is really broad. And the other thing is that when we lifted the whole device, it gave a better angle. So it showed how the angle really makes a big difference.